All right, so we're going to continue our practice with u substitution on a definite integral. So I have the integral from 1 to 5 of x times the quantity of the square root of 5x squared minus 4. 5x squared minus 4 dx. So immediately I'm going to turn around and rewrite this as 5x squared minus 4 to the 1/2 power. So what's my u? My u is 5x squared minus 4, which makes my du 10x dx. So I've got the x, I got the dx, I need a 10. So use a 10, multiply by 10, divide by 10 to balance. So my 1/10 is coming along for the ride. I need to change my limits of integration, so go ahead and go to this equation, sub in a 1. So 5 times 1 minus 4 gives me 1, which is okay. Sub in a 5, so 5 times 25 is 125, minus 4 is 121. And then I've got a u to the 1/2 du. So when I integrate, and I'm going to go ahead and multiply this into my denominator, okay? I'm going to get a u to the 3/2 over 3/2, which is times 2/3. And the 3 times the 10 gives me 30. So I have u to the 3/2. And now, oops, sorry, 120. Look at that too. That says 121. Okay? All right. So I'm going to sub in a 121. So remember, I'm going to do the square root first. So the square root of 121 is 11. And then 11 to the 3rd is 1331, I believe. It is. Okay, times 2 gives me 2662 over 30. So 2662 over 30 minus, and now I'm going to shove in a 1. Well, 1 to any power is 1, so I'm subtracting 2 over 30, which gives me 26,660 over 30, which will reduce to, math, enter, enter. I get, hang on, I screwed up somewhere. I did not screw up anywhere. All right, that reduces to 266 over 3. I was looking at the wrong problem. All right, so I got 266 over 3. Okay, so let's do another one. We have the integral from 0 to 2 of x squared times x to the 3rd plus 1 to the 3/2 power. So I don't have to rewrite this time. My u is what's on the inside. My du is going to be a 3x squared dx. So I've got the x squared, I got the dx, I need 3. So multiply by 3, balance with a 3. So I'm balancing with 1/3. Okay. So I now have 1/3 times the integral. If I sub in a 0 into this equation, 0 to the 3rd plus 1 is 1. Sub in a 2. 2 to the 3rd is 8, plus 1 is 9. And now I have u to the 3/2 du. Okay, so how do I integrate this? U to the 3/2, 3/2 plus 2/2 is 5/2. So I get u to the 5/2 divided by 5/2 is times 2/5. So 2/5 times 1/3 is 15. And now we're going to take this from 1 to 9. So if I sub in a 9, I'm going to do the square root first. So the square root of 9 is 3. 3 raised to the 5th power is going to be slightly big. 3 raised to the 5th power is going to be 243. Times 2 gives me 486 over 15. So 486 over 15 minus, when I sub in a 1, I'm just going to get 2/15. So 486 minus 2 is going to be 484 over 15, and that does not reduce. So 484 divided by 15 does not reduce. Okay? All right. Let's do a couple more. So we have going from 0 to 2 of x squared times x to the third plus 1 to the 3/2 dx. So my u is x to the third plus 1. My du is 3x squared dx. I got the dx. I got the x squared. I needed 3. So balance with a 1/3. So 1/3 times the integral. Go to this equation. And sub in a 0. So 0 cubed plus 1 is 1. 2 cubed plus 1 is going to be 8 plus 1 is 9. And then I have u, I don't know why I just put parentheses there, to the 3/2 du. Okay? I'm going to get really mad at this exact same problem. Anyway, all right. So when I integrate, u to the 3/2 becomes u to the 5/2. Divided by 5/2 becomes times 2/5. So 5 times 3 gives me 15. And I'm going to evaluate that from 1 to 9. So do the square root first. The square root of 9 is 3. 3 to the 5th is 243. So I get 243 times 2. This is the exact same problem. Hang on. It is the exact same problem. Whatever. All right, so I end up with 484 over 15. Sometimes the randomization of this thing does not exactly work. All right, so when you evaluate this, you'll get 44 over 15. All right, we have going from 0 to 5 of 6 over the square root of 2x plus 1 dx. So I'm going to go ahead and rewrite that. Going from 0 to 5 of 6 times 2x plus 1 to the 1/2 power. But I brought it up to the numerator, so I moved it, so change its sign to a negative. Okay, so my u is 2x plus 1. My du is 2 dx. Well, I have a 6 dx. Okay, so there's a 2 in here. I could multiply by 2 and then divide by 2, but that's really a big mess. So what I'm going to do is recognize that this thing is 3 times 2, and I'm going to leave the 3 on the inside. But, I'm sorry, I'm going to leave the 2 on the inside and pull the 3 out. So what I really have is 3 times the integral from 0 to 5 of 2 times 2x plus 1 to the negative 1/2 dx. So that's still a 6. Okay, there's your 6 right there. I still have 6. It's just that I only needed 2. So I just pull out the unnecessary part. So now I'm got my 3 coming along for the ride. If I sub in into this equation, if I sub in a 0, 2 times 0 plus 1 is 1. If I sub in a 5, 2 times 5 plus 1 is 11. And then I've got a u to the negative 1/2 du. And when I integrate that, I will get u to the positive 1/2 over 1/2 means times 2. So what I really have is times 2. Don't forget him. That's where the 6 came from. So 0 to the positive 1/2. And I'm going to take that from 1 to 11. Okay. So what do I have first? Well, u to the 1/2 means the square root of. The square root of 11 is not pretty. So we're going to put the square root, or 6 times the square root of 11 minus 6 times the square root of 1. Well, the square root of 1 is 1. So I end up with 6 root 11 minus 6. Okay? All right. And we have a final one. We're going to go from 0 to 27 of 7 over the square root of 2x plus 1 dx. Okay, so I'm going to go ahead and bring this up to the top. So I've got 0 to 27 of 7, and then I have 2x plus 1 to the negative 1/2 dx. Okay, So this time, my u is a 2x plus 1. My du is a 2 dx. Well, I have a 7. Okay, so now you have an option. I only need 2 of it, but 7 is not evenly divisible by 2. What you could do, and we could have done this on the last one too, is pull out that lead coefficient and pull it out front. So I'm going to go from 0 to 27. And now I've got a 2x plus 1 to the negative 1/2 dx. I got the dx, I need a 2. Okay, so if I need a 2, I'm going to divide by 2. Okay, now think about that. On the last one, what did we do? I lost my paper. On the last one, we divided out, I have no idea where my paper went. Oop, okay, on the last one, I had a 6. So I divided out what I needed, and that left me with a 3. On this one, I have a 7. So I divided out what I needed, and that left me with 3.5. Okay, so you could have pulled it out that way. All right, so I have 7/2 times the integral of sub and a 0 into this equation. So 2 times 0 plus 1 is 1. 2 times 27 is 54, plus 1 is 55. And then I have my u to the negative 1/2 du. So when I integrate, that becomes u to the positive 1/2. Over 1/2 means times 2. So 7/2 times 2 is just going to leave me with a 7. Okay, 7/2 times 2 is going to leave me with a 7. So I'm going to go from 1 to 55. So using direct substitution, remember that's just a weird way to write the square root of. So I'll have 7 times the square root of 55 minus 7 times the square root of 1. Well, the square root of 1 is 1. So I end up with 7 root 55 minus 7. And that is section 6.5.